can take the another two example to explain the stoichiometry, how it is useful in chemistry. So the second example what I have taken, that is what volume of oxygen at S.K.P, standard temperature and pressure, can be produced by 6.1 gram of potassium chlorate according to the reaction. The reaction is given to you. This is KClO3 potassium chlorate. Potassium chlorate. So how to solve? So you know the method. What is the method? First of all, we will write the balanced chemical equation. First of all, we will write the balanced chemical reaction. So it is the balanced chemical reaction. Dissociation of potassium chlorate. You know that when the potassium chlorate is heated in presence of manganese dioxide produces oxygen. All details are not written here. So only these two products which is produced is written according to the requirement of the question. Now according to equation you write the molar ratio. What is molar ratio? It is 2 mole. 2 mole of potassium chlorate undergoes dissociation and produces 2 mole of potassium chloride and 3 mole of oxygen. What has been asked to calculate? What volume of oxygen? What volume of oxygen is required? Okay. So now you can see here. So 2 mole produces 3 mole. So this much gram of potassium, how much it will produce? So now the question what is given? This much gram of potassium chlorate is taken. So that's why I have written here. What has to be calculated? Volume of this oxygen has to be calculated. So first of all, I will convert this mass into the number of moles. In the previous lecture we have discussed. In chemistry, always we calculate in terms of mole. Then the calculation become easier. If we calculate in any other units, it will become difficult calculation and even it will become time consuming. So here also we will calculate with the help of moles only. So that is why we convert this mass of the potassium chlorate into number of moles. So how to calculate the number of moles? Actual mass divided by molar mass. So 6.125 gram is the actual mass of potassium chlorate and 122.5 is the molar mass of potassium chlorate. Now how to calculate the molar mass? You know that. Add all the atomic masses of potassium, chlorine and oxygen, you will get 122.5. So this is the molar mass of potassium. Calculate. You will be calculating yourself. So this is the number of mole of the potassium chlorate we have got. So how much this number of moles will produce this oxygen? So calculate it according to the equation. 2 mole of potassium chlorate produces 3 mole of oxygen. So therefore 1 mole of potassium chlorate would produce 3/2 mole of oxygen. That's why this much mole. How much it will be multiplied here? The method of the unitary. You know that. Accordingly, we will calculate it. So after calculation, we are getting 1.5 into 0.05 mole of oxygen. Now we need in volume, and you know that at S.K.P, any gas, 1 mole of any gas occupy 22.4 liter of space. That means irrespective of the nature, irrespective of the molecular formula, nature, color and everything whatsoever, at S.K.P the volume of 1 mole of any gas is nothing but 22.4 liter. So 22.4 liter is the volume of any gas available in this universe at S.K.P for 1 mole. If you take 1 mole of any gas, their volume certainly be 22.4 liter at S.K.P. So that is why we will be using that value to calculate the volume. So that is why 1 mole of O2 has got the volume 22.4 liter. That is why it is multiplied it, and finally you are getting 1.68 liter oxygen. So this is your answer. That means 6.125 gram of potassium chloride. 6.125 gram of potassium chloride would produce 1.68 liter of oxygen at STP. 1.68 liter of oxygen at STP. Okay. Now next question. What mass of zinc is required to produce hydrogen by reaction with HCl? That means there will be reaction between zinc and HCl and that will produce hydrogen gas, which is enough to produce 4 mole of ammonia according to the reaction. These two equations are given according to the equation. This is one of the equation. This is one of the equation. This is another equation. This is the equation Zn plus 2HCl, ZnCl2 plus H2. This is the equation to produce hydrogen. And 3H2 plus N2 produces ammonia. This is the equation to produce the ammonia. So both the equation we have got now. Now according to equation we will write 1 mole of zinc reacts with 2 mole of HCl, produces 1 mole of zinc chloride and 1 mole of hydrogen. Again 3 mole of hydrogen reacts with 1 mole of nitrogen and produces 2 mole of ammonia. What has been said in the question that we want to produce 4 mole of ammonia. We want to produce 4 mole of ammonia. We have to produce 4 mole of ammonia with the help of zinc. Zinc directly cannot produce ammonia. Zinc cannot produce directly ammonia. To produce ammonia we need nitrogen and hydrogen, and we have to produce 4 mole of ammonia. And to produce ammonia we need hydrogen and nitrogen. Nitrogen is made available to us, but hydrogen was not available. So we have to produce hydrogen to produce ammonia. Okay, and we have to produce the 4 mole of ammonia. So that is why we have to calculate in terms of that, and to produce hydrogen we need this reaction. Zinc must be made to react with the hydrochloric acid so that we can get zinc chloride and hydrogen. So with the help of this reaction we will have the hydrogen, and then this hydrogen will be made to react with this nitrogen so that we can produce the ammonia. So we have to ultimately produce the 4 mole of ammonia here, and to produce the 4 mole of ammonia we have to calculate how much zinc is required. So first of all I will find to produce 4 mole of ammonia how much hydrogen is required, because hydrogen would be produced with the help of zinc. Zinc cannot produce ammonia directly, but hydrogen is needed to produce, and that hydrogen will be given by zinc. Zinc would react with hydrochloric acid and it will produce hydrogen. So that is why we will calculate from this side. So first of all I will find out how much hydrogen is required to 4 mole of ammonia. So once we get the idea about the hydrogen what is required, then we will calculate that much hydrogen will be produced by how much of zinc. So first we will calculate how much hydrogen is required to 4 mole of ammonia, to produce the 4 mole of ammonia. Okay, now 4 mole of ammonia we have to produce. So according to equation 2 mole of ammonia is produced by 3 mole of hydrogen. According to this equation 2 mole of ammonia is produced by 3 mole of hydrogen. So we will be writing like that: 2 mole ammonia is produced by 3 mole of H2. So that is why 1 mole of ammonia is produced by 3/2 mole of hydrogen. That is why the 4 mole of ammonia would be produced by 3/2 into 4 equal to 6 mole of hydrogen. That means to produce 4 mole of ammonia we need 6 mole of hydrogen. To produce 4 mole of ammonia we need 6 mole of hydrogen. Now that means to produce 4 mole of ammonia we need 6 mole of hydrogen. So we have to produce 6 mole of hydrogen. So that is why we have to produce 6 mole of hydrogen, because 6 mole of hydrogen is needed to produce 4 mole of ammonia. That is why we will be finding out how much zinc is required to produce 6 mole of hydrogen. According to this equation 1 mole of zinc produces 1 mole of hydrogen. So 1 mole of hydrogen is produced by 1 mole zinc. 1 mole hydrogen is produced by 1 mole of zinc. So that would be 6 mole of zinc would be produced by 6 mole of zinc. 1 mole of hydrogen is produced by 1 mole of zinc. So that is why 6 mole of hydrogen will be produced by 6 mole of zinc. And then the mole will be converted into mass. Zinc is not a gas. It's a solid particle, so it should be converted into its mass. And we know what is the molar mass of zinc. Molar mass of zinc, how much? It is 65 gram. Molar mass of zinc is 65 gram. So 1 mole zinc equal to 65 gram. 1 mole of zinc equal to 65 gram. That's why the 65 is multiplied here. So ultimately what we are getting? 390 gram of zinc. That means 390 gram of zinc would be able to produce 4 mole of ammonia. 390 gram of zinc would be able to produce 4 mole of ammonia. That is the need of this question. That is the final answer. Okay, thank you.